So, hello and welcome. This is a talk called Object Reorientation. The idea is try and go a bit beyond the standard object-oriented design rules that you might have already come across, like solid and dry, and instead look at how we can leverage the power of object-oriented design to write code which is easier to understand, change, and reason about. I'm going to be introducing some design principles and rules during this talk, but one of the important things to take away is not a hard and fast set of rules to apply, but a set of guidelines which you can use to help shape the structure of your code. The most important thing to learn about any rule in software engineering is not to know what it is, but to know where and when it will help you out, and where and when you can safely ignore it and potentially break the rule, which will make it a better implementation. So why do we want to do this? You may be wondering what the motivation behind applying the techniques I'm going to go through today is. If the code works, is that not good enough? For most code you write, at some point in the future, someone, probably you, but it might be me, in which case, doubly reason for making sure it's good, right? Is going to be looking at it, trying to figure out what it does and how it does it. We want to try and give future you a helping hand in understanding that code. And by improving the structure behind the code, we increase our ability to change and adapt it in future. And by increasing the quality of the code, we also reduce the number of defects. So one thing you might have already come across, solid. It's a design principle. This talk isn't going to really focus on it. It's a set of rules. But there's probably a few people who haven't come across it before. So for their benefit, and for the benefit of everyone else in the room, myself included, who can never quite remember what the O or the I stands for, we'll go over it really briefly. So the first the S in solid is the single responsibility principle. It's the idea that every class or module in your system should have one responsibility, one reason to be changed. This can be quite a large responsibility depending on the layer of your application in which it resides. For example, a router has a responsibility of routing all inbound requests, which sounds like a fairly broad responsibility, but it's still a single purpose. But you shouldn't need to use the word "and" when you're describing what it does. Okay. The O stands for the open-closed principle. There's two different definitions for this one. The first is the idea that a class or module in your codebase can either be open, so that you can add new functions to it, or closed if it's available for other classes and modules to depend upon. The second is sort of similar but along the same lines, but it applies more to polymorphism. So the idea that an interface of a class, the defined methods and their parameters, are closed to modification, but the implementation inside that method is open to be changed if need be, provided the external interface to other classes remains the same. The L in solid is the Liskov substitution principle. This is a principle that allows us to substitute one implementation of an interface, so for example a database interface, for another one without affecting the correctness of the program. Your code should still be able to save and load data. So you define an interface with some methods, save, load, update, delete, that kind of thing, and you can have multiple different implementations, all of which will do the same thing and can be used interchangeably by your codebase. The interface segregation principle. The idea behind this principle is to ensure that interfaces on classes are kept to a minimum, e.g. they only contain the methods necessary for that interface. This is kind of related to the single responsibility principle, but sort of applying to interfaces. So you should have, it's perfectly allowed to have several interfaces being implemented on a class, but you should separate those interfaces based on purpose. And the final, the D in solid, is the dependency inversion principle. That's the idea that your code should rely on abstractions and not concretions. So wherever possible, you should rely on an interface as a dependency rather than the underlying implementation of that interface. These rules are quite abstract and high level, You'll sort of see that some of these, or some of the things I'm going to show later on in the talk, you'll sort of see some of these things come in, and you'll be like, oh, that's a bit of a single responsibility principle. But we're not going to talk any more about them during this talk. The other thing you might have come across, it's quite oft-quoted, is DRY. It's got a nice acronym. For anyone who's not heard of it, it stands for Don't Repeat Yourself. Okay, so the idea of keeping code dry is to try and remove duplicated logic from the code. Obviously, this has many advantages, such as reducing the effort to write and test the code in the first place. And it also means that you don't end up introducing inconsistent behavior in your application, where you change logic in one place and not in another. There's a sort of a bit of a saying that people say, if you've duplicated a piece of code logic n times, when you need to change it, you'll always end up changing it in n-1 places, which will introduce a bug, of course. Dry is one of the rules where you really need to know where and when to apply it, though, because sometimes two bits of code might look the same but represent different concepts. They have different reasons that they might want to change. Consider a shopping cart, which might have a limit of 3 products because they're currently on a promotion. So you might only be able to add 3 of a particular product type to a basket to make sure that every customer can benefit fairly from this promotion. You might also have a shipping object in your code base, which would allow you to add just 3 products to shipping, but that might be for a health and safety reason. For example, if you're selling gas canisters or something like that, there might be a legal regulation that says you can't ship more than 3 of them in one shipment because that might be dangerous. So although those 2 pieces of code, a limit of 3 products, look the same, they have different reasons to change. If the law changes, becomes stricter and says you can only send out 2, you don't want to change the amount that your customer can add to the basket because of the promotion. Vice versa, if the marketing team decide they want to open the promotion up and allow you to send 5, you don't want to inadvertently allow your system to ship 5 gas canisters out in a single shipment. Okay, so it's one of these that you have to be sort of careful when and where to apply it. So before we move on, I've got a question for the room. What do you think is the hardest part of software development? Okay, so who thinks it's writing the code? Hands up if anybody thinks the hardest part of software development is writing code. Oh, quite confident in writing code here. Okay, who thinks the most difficult part is writing some tests? Oh, good at testing as well. We've got a good room here. Okay, who thinks it's debugging code that doesn't work? That's quite a hard one, right? Yeah, a few people think it's that. So I'm guessing everybody else thinks it's actually the hardest part of writing software is something else. Is that right? Yeah? Okay, well, let's see if we can answer that question in the rest of this talk. So the first section of this talk is mostly for the few of you that did find that debugging code that doesn't work is one of the hardest parts of your job as a software engineer. I'm going to outline a few techniques I use to reduce the rates of defects and bugs in my code, which you can probably use as well. I should point out that these techniques go hand in hand with good unit tests. They're not a replacement for unit tests, but they will reduce the number of tests you need to write in some instances. But you still need the test to guarantee that your software works. These are in addition, if you like. So the first sort of rule, guideline, however you want to say, that I'm going to produce is write code which reduces the number of possible invalid states. Okay? Sounds quite abstract, so let's have a look at a piece of code. In this example, we have a function. It's got 2 parameters. And it's not immediately clear from the method signature that there's actually a business rule in play in this function, where based on whichever parameter you pass in, you can only pass one or the other. So there's 2 invalid states there. If you pass in both true, true, that's invalid, and if you pass false, false, that's actually invalid. So you've got 50% of the possible sets of options you can pass to this method are invalid. We could perhaps refactor this to have only a single parameter, bar or baz, and assume it's bar when true, baz when false. That might be a slight improvement. And while this change would help, the person calling it is still not going to be particularly aware of how this business rule is implemented. Is it bar when it's true or bar when it's false? It's completely ambiguous just from the method signature. They'd have to dig into the code. We could refactor it a bit like this instead. So we have a method does the same thing, but this time we pass a parameter in. Oh no, that's the bar or baz code. Got ahead of myself there. So yeah, you can see here we're passing in maybe a boolean, and if it's true, we do bar, and if it's not, we do baz. What we could do that would be better, maybe something like this. So we define some constants which represent those two possible modes, and we can use that to determine which method, how we actually perform the business logic inside this function. When someone's coming to actually use this code that you've written, it's a lot more clear to them what they actually need to do. There is a mode, it changes depending on some sort of external condition. And you're telling them up here what are the two modes that are valid to pass. There's foo and there's bar. And that's a lot easier for people to understand, and there are a lot fewer invalid states. Someone's not going to accidentally pass the wrong mode, or it's a lot harder for someone to accidentally pass the wrong mode because it's quite explicit what the correct ones are that they can pass. Okay. So we move on to the next rule. An object should always be in a valid state. So if you've created an object, it shouldn't be possible to create one that is invalid after you've created it. Let's take a look at an example. Date range. You've got a start date and end date. You probably use these. It's a fairly common thing to need in the code base. And what we've got here is we've got some setters and we've got some getters on the code, so that you can set a start date and an end date, and then once you've done that, you can check, is this object valid? What if someone's writing some code with this date range and they forget to set an end date? Well, it's not valid. What if they forget to call the isValid method and haven't really checked things? You've got this object kicking around in your code base that has got invalid dates in it. That could end up getting persisted into your database and propagate bugs in your code all the way through your system. If this went out a few years ago and you've got loads of invalid dates in your database, and you've suddenly changed some rules that now the requirement is much stricter, you're suddenly going to have a load of records in your database which don't work for some unknown reason. Okay, so you're sort of storing up bugs here that future you is going to have to deal with. We could refactor that to look a little bit more like this. So instead of having individual setters for those two properties, we know that there is a rule that they have to be sort of temporary in order. Okay, the start date has to be before the end date. So we'll enforce that when we create the object. We enforce that we've both got a start and an end date because it's not valid without. And when we construct it, we actually do that isValid check immediately before we update the actual properties of the object. Equally, if we need to change in the future, we've got an update method which does the same check and ensures that that object can never be in an invalid state. So you can now be confident to rely on this object. You can sort of say, if you pass this around in your code, you've got a date range, you know that that object is going to be in a valid state and you don't have to worry about checking it yourself. You can rely on it. It's going to help you reduce bugs, because if you've got a bug in your user input validation, for example, where it's not validating that a date is before another date, and it's passing invalid data in, the moment that you try and create this object, it will throw an exception and it stops dead there. So that bug doesn't progress through your stack. It stops at the point at which you create this object. Okay, it acts as a hard barrier and stops that bug from progressing further. So when you're looking and saying, well, why is my code not working? Well, you've got an exception. You can have a look back up the stack and you can say, well, it was clearly someone passed in a null end date. Oh, look, someone typoed a parameter from the variable name, and that's why it's not passed in a valid. But the bug has stopped right there. Okay, So it makes it far easier to find out where that bug is. Move on to the next guideline. Try to encapsulate internal state inside your objects. So what I mean by that is if you've got an email address class like this, we've gone to all the effort from the previous slide. We've applied the rule of saying, well, okay, we're going to make sure that a string is passed in. We're going to validate the email address, make sure it's valid. You know, it's not an empty string. It's got an app symbol in it. I might even do some complicated validation and make sure that the domain name actually exists and it's a registered domain name on the internet. Some validators I've seen do that. And then once we've done that, we're going to set it into the property, and we're going to leave it like that. Trouble is, sometimes people do all that work and maybe they leave the property public. So although you've got the guarantee that that email address was validated at the point you created it, you've not got the guarantee that someone hasn't gone along and changed that public property or called the set email to change it without doing the validation. So once you've got that nice valid internal state, you want to protect it. Make properties read-only unless they're going through the same validation rules. Make properties private so that they can only be accessed within the class. If you need to be able to provide external access to the raw data inside that object, for example, if you're trying to send an email, you'll need the raw string email address. Provide a method to get at it. Don't just make it a public property, because obviously if it's public, anyone can read and write to it. Whereas if you protect it by just allowing read-only access through a get method, then you make sure that variable not only starts in a valid state, but remains in one. Again, that's going to help you reduce the level of bugs and things like that in your software. That moves us quite nicely onto my next thing, is try and use type hints. You'll see that some of the code examples I've done already use type hints. We've got PHP 7 now, which gives us a range of nice string and scalar type hints and things like that. Once you've validated that email address or that date range or things like that, using type hints in your code helps make sure that you've got a valid object that is an email address. You can be sure that that is an email address when you've got one. Okay, you can trust that variable. Whereas if you have a class that looks a bit like this, you've got no guarantees that what's being sent in is actually valid for what you need. I mean, do we send is the subject, should that be a string, or should we be sending in a subject object which encapsulates something and ensures that it's got a string length greater than 4, for example? That might be a rule there. You don't know. And without that type hint guarantee, you've probably got to redo some of your validation logic because you've not guaranteed that what you've been passed is actually valid data. The type hints on there protect the internals of the method, because if you've said, well, we trust, we've built this email address object up, we've got some validation, we've got unit tests which prove that validation works, so we can be pretty confident that that email address is a valid email address. If you type hint it into a method, that's a bit big, isn't it? You can then ensure that you've got a valid email address when you're passing it into here, and you don't actually need to redo that validation work. You can just trust the value you've been passed. Equally, okay, we're saying, well, we've not got any particular validation rules on subject other than it's got to be a string. And same with the body. Obviously, you're free to change this, but that's just an example. Going on to the next rule. This one's a little bit more controversial, I find, sometimes. But it's a good idea to either change state or return a value. Don't try and do both within the same function. Something like this method. I saw something similar to this in a code base I was working on about 1.5 years ago. Had a basket which had a method on it to calculate a discount when a discount code was applied. And this was called with and what it would do is it would discount the total on the basket by the discount amount and then return the amount of discount that had been applied. This was used in a view file, a bit like this. think there's a few of you possibly seeing where this is going to go wrong. Ah, no. You see, this was how it was laid out on the checkout page. But then the marketing team thought, people aren't quite aware of how much discount we've given them. They're not aware of how much they've saved. So we want to put a nice big H3 across the top of the page and tell them what the discount is. Now, if we go back to the code on the previous slide, I think you can probably all see what went wrong there. They got a bigger discount once they checked out because it got called twice. Obviously, the way we can resolve this is by having two methods. We have an apply discount method. We'd probably call it a controller rather than a view. That was another mistake that was made there. Should have been on a controller. And then when we actually pass that basket through to render it, we don't have to keep on applying a discount every time we want to find out how much the discount amount is. We can just get the value off it. Okay. This little technique here, this little trick might save your business a bit of money. I don't know. Fortunately, it was picked up in a code review, so it didn't actually go out live, but yeah, could have been expensive. Another thing to be careful with is mutable values that can change. So with PHP, every time you pass an object into another method call or function call, you get the same object. It's the same object that's passed around. When you're dealing with strings and numbers and things like that, it copies them, so you get a copy of the string. So if you change that string within your function body, it doesn't affect the outside world. If you pass an object into a function, it will pass the same object. So if you change that object, it's changed everywhere. This could go wrong a little bit like this. So let's say you've got a user entity. Probably all got a user entity in your system, I would imagine, which has a join date. Okay. The join date is a datetime object, and you've got a getter method on there to allow it to be returned. Now, you've also got a service which is applying some sort of bonus once someone's been signed up for a year. I don't know what the bonus is, but it's not necessarily important. So what this service does is it searches for a load of users, finds those that have been a member for more than a year, and applies the bonus, and then it saves it down to the repository. I don't know if anybody can spot where the bug is in this code. Over here. This one as well. Slide. What that will actually do is that adds a year to the join date object. So it's the same object in the user entity that we are using in the service. So that we actually changed the value of that date object. So it means that once we've applied our join bonus and we save that user entity at the bottom there, it will actually change the user's join date forward a year. This happens quite frequently. I've seen this occur a number of times where people have grabbed datetime objects, not realised that doing things like adding and subtracting dates, doing mathematics on it, will actually change the underlying object and cause bugs because of it. What we can do, a few options. PHP 5.6 and above comes with this datetime immutable. And it's got a create from mutable function, so you can just pass in the join date as it is. Another option, obviously, that's sort of specific to date times. So another option, if you've got an object of your own which can mutate in this way, is to just return a clone of it using the clone keyword. Maybe a better way, though. We'll have a look back at the service. What we could do is we could move that logic that checks that join date onto the user entity itself. Obviously, the user entity knows when it joined, so it's the best object in our system to answer the question of, have you joined before a certain date? And by doing that, the user object itself is in control of that change to the method, and we've got a nice little sort of helps people who are coming back and reading it later on, because they're sort of saying, okay, we're trying to find out if the user entity has joined before. If you remember the code on the previous slide, that's a little bit more, you have to do a bit more thinking to try and figure out what's going on there. Whereas here, join before, okay, you read that, you kind of know what's going on, right? Bit easier to figure it out, bit easier to, and obviously that's also preventing that bug. So there's a few techniques that you can use to sort of reduce bugs. But go have a look at the other side of things. It's what I think is the most difficult part of software engineering. Once you've learned a language and you're familiar with the development tools, you know, your Node.js stack or your IDE and Docker and how to get code written and deployed out onto a server. Once you've learned all of that and you're confident doing it, once you've learned your programming languages and your frameworks and you're confident using them, I think the hardest part of software development is not writing code. It's not even debugging code, particularly, but it's the time that we need to take to learn about the problem we're trying to solve with our code. If you reframe the task of writing code from one of writing some instructions for a machine to execute, which is really what we're doing, but instead look at it as a task of trying to encode what you've learned about a business problem very precisely in a programming language so that others, not only machines, but other humans, can understand what you've learnt from your code. So they don't have to redo that hard work of learning what is all the business logic, what's all the edge cases, everything like that around this particular scenario before they can do work on that part of the code base. If they need to make a change or refactor something, fix a bug, you're trying to encode all the things that you've learnt from your business experts, from the product owners and product managers and things, into that code so that the developer that comes after you doesn't have to learn and spend all the time that you spent learning about that problem. So this next section is going to be having a look at how we can better embed knowledge into our code base. So I'm going to take a look at, I'm going to do this by looking at a case study. This was some work I did for a client, again about a year and a half ago. The client worked in fintech, shall we say. They were handling money on behalf of customers, essentially. In order to do that, they needed to collect bank details from users. And when you're dealing, I don't know how many people of you do any fintech stuff, but when you're dealing with other people's money, they tend to get a bit angry if you put it in the wrong bank account. So making sure that when they give you bank details, they are actually the correct bank details is quite important if you're doing some sort of like fintech work like they were. So I mean, this was a British client. So British bank account has a sort code. Consists of a 6-digit number. Usually it'll be written out separated by dashes. This sort code identifies the branch and the business, the bank business effectively, and the branch, the bank that the account belongs to. So it's sort of like a routing code, if you like. And then an 8-digit, usually, account number, which identifies the specific account at that bank. Okay, and it differentiates it from other people's account, obviously. So, you know, you look at the rules I put up on the slide there, you might think, well, okay, we've got a 6-digit number, and we've got an 8-digit number. So you might have a stab at it, write something like that. Check the account number and the sort code are in fact numbers and not strings. Check they're the correct length. Strip out those dashes just in case the person typed in with them. Do a bit of validation. That might work. Turns out it's quite a bit more complicated than that. Bank account numbers also have what's known as a mod 11 check. So this check basically splits the number into its individual digits. Sometimes it includes the sort code as well. And then it multiplies each one of the digits, each one of those 8 digits, by a different constant. So say you've got the account number 1, 2, 3, 4, 5, 6, 7, 8. It'll multiply 1 by the first constant, which might be a 4. Then it'll count 2 by the second constant, which might be a 7, and so on and so forth. And then it'll add all of those up. at the end. That number then gets divided by 11, and then the remainder is compared to another constant. That is usually 0. So once you've multiplied the bank account number, each individual number in the account number, by the constants, and added them all together, when you divide it by 11, the result should be 0. Okay? Easy. We can implement that function. So where do the... so you implement a function that looks a bit like that. Does the mod 11 check. And then you go to the product owner and say, so where do those constants and expected results come from? The product owner says, that depends. On what, you say? Well, I've got this really big data file, and it lists all the constants and expected results each different bank in the UK uses. Oh, and you know how it's a mod 11 check? Well, not always. Some banks use mod 10 instead. There are some other rules that banks use as well. It's probably best if I give you this technical specification. Cue about a 25-page document detailing lots. So what's the problem? Well, the technical specification and clear rules. So it should be easy to implement, right? Well, yes and no. The previous developer of the validator that this company was using certainly thought it would be easy, and proceeded to write this really huge long service class which parsed the data file, great, into a PHP array, and then use that array to look at which rules to apply, given a sort code, and then use a doubly nested switch statement to apply them to the account number. Now, that'd be fine if it worked, because you'd never have to touch it. It would be one of those things, oh, we don't touch that. We just leave that. We don't touch that code. But where I came in was customer services. Here's a list of bank accounts that customers have. They're actual valid bank accounts, but the system says they're not. Can you fix it, please? Now, if I asked you to guess if that huge service class had any tests, you'd probably guess wrong. It did, in fact, have tests. 2 of them. One for a valid bank account and one for an invalid bank account. So what do you do when faced with this problem? You add another test. Bank account that the customer service person says, put that in. Oh yeah, it fails. Doesn't go through the validator. What now? You're faced with a failing test, a huge couple of thousand lines of code, no useful comments. What do you do next? Write more tests. Helpfully, the tech spec came with a whole bunch of test vectors. It was like a whole page at the end, an appendix dedicated to, here's some account numbers for each of the different rules that this specification details, and these are ones that pass and these are ones that don't. So I went, right, okay, well, let's see how big this problem actually is. I turned each one of those test vectors into another unit test. It was even more broken. About a third of the test vectors failed. Either failed positive, validated an account that was invalid, or failed negative, or just threw an exception and couldn't handle it at all, which was helpful. So armed with some tests that were failing and some that were passing, I now decided that we're going to throw away that. Completely useless. And we're going to refactor it, I'm going to redesign it, and use that specification to help us code something which will mean the next developer doesn't have to read that specification. Okay, so what did I do? First thing I did was the tech spec defined a number of different rules, about 14, I think. They were all variations on the mod 11 or maybe mod 10 validation pattern, and the sort code given would usually determine which of these rules were to be used. However, there were some instances where the rule used would differ depending on the account number as well. There was also an instance where sometimes you'd have to apply 2 rules and they'd both have to pass for it to be considered valid. So the first step I took was to create a separate create an interface, a rule interface, and create a separate class for each one of these different rules. This would replace that huge nested switch block in the service class and gives an immediate jump in in knowledge sharing with the next person to come along. Someone unfamiliar with the code could have a look at the tech spec and say, oh right, there's 14 rules, rule 1, rule 2, rule 3. They can have a look in the code base and they'd say, oh look, there's a class, rule 1, rule 2, rule 3. Okay, we're getting somewhere. They wouldn't have to read the detailed specification of how to implement those because they can probably trust that rule 2 implements rule 2. And we've got some tests that prove it works. All good. That might be where we stopped, but I decided to go a bit further. I mean, one of the validator class. So I replaced the validator class with a much simpler one. As we delegated the work to actually enforcing these rules into those separate classes, the validator class itself was now solely responsible for determining which rule to run. So all that it had to do was load that data file into an array, and when you gave it an account number and a sort code, it consulted that array and said, okay, sort code 1, 2, 3, 4, 5, 6 means we need to apply rule 7. So we'll load up rule 7 and we'll see if it works, and return a Boolean. Now, again, could have stopped there. That fixed the bugs. We had the customer service people would have been happy. Our customers could have submitted valid bank accounts. But part of the remit that was given by the development manager was, can we make this whole process more robust? Because we're using this validator all over the place. And we'd really like to stop having to validate bank accounts all over the place. They're validating every time they send a payment, they're validating every time they change the details, everything like that. So can we make it so that we only have to validate once? Okay. We'll introduce a value object. If you were paying attention earlier, you know that my preferred way of doing this is to create an object which retains its validity, enforces validity. So I constructed an object which had some properties for sort code and account number, and we also added a few methods such as equals, so that we could compare and keep the knowledge of what bank account is within that class. If you want to find out if a customer's changed their account details, are they the same as the previous ones? Well, we've got an equals method for that. We'll just call it. And we also added some constructor methods to that. That's a bit more complicated to see. And if you remember, we always want to make sure that this account is in a valid state. We could have fudged it a bit and said, well, we'll use the validator to return a value object of this type. But because I want to make sure that the object itself is completely in control of its own validation, what I decided to do was pass the validator itself into the object constructor. You'll notice I'm using a static method for this. The reason for that was we had multiple ways to construct it. Although you could construct it from a sort code and account number, you could also create one from an IBAN object, which was a separate part of the solution that I'm not showing here. So we had the static method which allowed you to create it from 2 strings and a validator. And then the object then could enforce that the validator had returned a true value for those details. And therefore you know that when you've got a bank account object in your code base, it's a valid bank account. So we can eliminate validating it when we send out transactions, provided we've got a bank account object which we can type hint on. It's valid. That's okay. We've also reduced the knowledge, again, of someone needing to work with this code in the future. If they just need to have a valid bank account, all they need is that type hint. They don't need to worry about how the specification works, what the rules are. All they need is a type hint. So you're reducing the cognitive load on other developers in your team. As a final step, I decided to make it a bit easier still, because knowing that you needed to pass a validator in, that's a bit, why do I need a validator? I've got an account number. So I had a factory class where you could pass in just a string of the account number and sort code, and the service manager of the application, Laravel, automatically would compose in that validator object, so that when you had your factory inside a controller, you could validate your user's input using this factory, and it would give you back a valid bank account object which you could then pass to the code base, and you have a nice solid guarantee that is a valid bank account which you can use to send transactions with, and that you can save in the database and everything like that. Okay, so a quick conclusion. Obviously, I've shown a bit of case study and some techniques you can use there for improving your own code. Obviously, they're not hard, fast rules, as I said at the beginning. They are guidelines. So apply them where you think they will help you. I also use, when I'm doing code reviews, I quite often use a few of these rules as sort of like a guideline for doing code reviews. If people have created objects which can have lots of invalid states in, for example, or they've forgotten type hints on things, they'll turn into code review comments and say, well, perhaps you could put a type hint on here, or perhaps we could take this array and turn it into an object, so we can type hint against that specific thing rather than just an array of data. I'm going to leave you with a quote from a famous computer scientist, Dijkstra. He said that the purpose of abstraction is not to be vague, but to create a new semantic level in which one can be absolutely precise. When we are solving a business problem, we are taking a potentially complex process from the real world, and we're building an abstraction in software, a computational model which reflects that process. The more precise the model that we build, the easier it will be for another developer, or you, in 6 months' time, to pick up from where you left off and update that code and build upon it to solve other problems. Thank you very much.